it recording now? Can you guys tell if it's recording?
Yeah, it's recording.
All right. So please do me a favor. And when I ask question, if you can answer, immediately do so. All right. So thank you very much. And I don't know why we're getting better picture today. Is it because dark outside or not? So don't mind my wardrobe. I just came from the gym and didn't get the chance to change. So this is why I get weird looks at the gym because of my shirt. This is the shirt I wore today. Anyway, so can you read it? What does it say?
It's a really nice quote.
Oh, can you read it? Read it
Yeah, I
loud.
can. Math is hard, so is life. Get over it.
Yeah, you see, the other day I was at the gym and that's try to do some lifting, and this guy came to me. He said, "Oh, I disagree with your quote." He said, math is easy for me, but life is so hard." And I said, "Well, I'm so sorry that life is so hard for you." So anyway, we're gonna do some math. I think I erroneously spoke last time and I said 4th of July is on Thursday. I don't know what happened to me. My wife corrected me yesterday. She said, "No, it's Friday. Friday, we don't have a class." So I know a couple of you are traveling, but it's recorded the class. So you know what? It's Independence Day. I love this country. And then I'm not going to have a class on Thursday. We're going to take a day off. Is that okay with everybody? I'm sure you're happy. You don't mind.
Yeah, that's great.
All right. So, and did anybody try to access the videos yesterday to rewatch?
I don't think the files option is turned on Canvas for like student view.
Is it?
On Canvas, the files tab isn't on there, so I don't think it's turned on for student view.
Oh, okay. Did you check YouTube?
I don't think I did.
There
no.
is a link under the syllabus page that takes you to YouTube, takes you immediately to the video. Anybody did the click on YouTube? No? All right, I will make sure that the file is turned on for student today, okay? Once we get the class. It was really hard to upload them both to file and this because they have to download. And it took so long.
The video is I can see the video from the YouTube, but from the Canvas, I think the Canvas cannot handle like the larger file. So for that, maybe what you can do is you can just put the video link in the Canvas or the YouTube link so that we can watch from there, maybe.
Okay, that's a good idea. So let me create a tab for video links or something, okay?
Yeah.
But it may have to ask you to log in. You have your credential, right?
Yeah.
If I do the link, you have to log in, okay?
Okay.
All right, so I will, yeah, okay, then I will do something else and I will email you whatever I do today. All right.
All right.
You see, it's good to have some input. All right. Okay, so we're gonna start. So most of you have access to the book by now, I assume?
Yeah, everyone has the book access because the Canvas is giving access till 9th of this month. Then you have to buy.
What did you say?
So Canvas is basically giving since the book is mandatory for the course, so Canvas is giving access till 9th. So you can assume that everyone has access to the book till 9th of July, but if everyone has to pay. So if you wanna like continue with the semester, then you have to pay for the book, or
All right.
you can buy the hard
Okay.
copy.
All right, thank you. Thank you. And you see, as an author, I have no control over anything. That's it. My only control is I write the book and I submit it, and that's it. I don't have anything to say in the price or access or anything at all. So anyway, so we're gonna talk about today section 1.3. This symbol indicates section. Okay. All right. So we're gonna take a look at the shift and delta difference. Recall, if xn is a sequence, then del xn is xn plus 1 minus xn, and that is e of xn minus xn, and you can write this as e minus I xn. Apply. I is the identity operator. That is I of xn is xn. You see what I mean? It just doesn't change anything. Okay? So we did this last time, so we can write it as e minus I xn and so forth. All right. So now we claim E is linear. So that is for sequences xn and yn and constant C1 and C2, we have E of C1 xn plus or minus C2 yn equal Cn E of xn plus or minus C2 E of yn. Okay, so this is what it means. So it's linear. That means you just can, it acts freely and nicely on other sequences. All right. And and E k of xn equal to E of E k minus 1 of xn. So you just, it's repeated, and that is xn plus k. Okay? So the k shift. So this is the k shift. The k shift. Okay? All right. And similarly, del of C1 xn plus minus C2 yn is C1 del xn plus minus C2 del yn. Okay? All right. So again, so the delta difference is linear, and the shift operator is also linear. All right. So let's see. Now, what about del k of xn? So that is in differential in calculus, that will be the kth derivative. So that is I equals 0 to k minus 1 to the I, k choose I, xn plus k minus I. Okay, it is in the book. There's a couple line of proof for it. It's in the book. Okay. So what does this mean? Or this mean equivalently? You remember delta is E minus I to the kxn is this one. Okay? Because we thought, we did say that, recall that delta is E minus I, where I is the identity operator. Okay? All right. So now you wonder about the product rule, the kosher rule, when it comes to differentiation. Remember? In calculus. So let's take a look. Recall in calculus, that if you have f function from R into R, f and g and f, two functions from R to R that are differentiable, then d of dt of f of t times g of t equal to f of prime is g plus f of g prime. Well, unfortunately, we don't have this luxury in the discrete case, in difference equation. On the other hand, if xn and yn are sequences, then let's do it together. Xn, yn. That is xn plus 1, yn plus 1 minus xn, yn. Is that right? So let's add and subtract xn, yn plus 1. Okay, let's do xn, yn plus 1. So this becomes del of xn, yn equal to xn plus 1, yn plus 1 minus xn, yn plus 1 plus xn, yn plus 1 minus xn, yn. So for this term, this is xn plus 1 minus xn, yn plus 1 plus xn, yn plus 1 minus yn, and that is del xn times e yn plus xn del yn. So there is the formula. Okay? You see, it's not the same. It's not the same as f prime g. It's f prime eg plus f g prime. So that is correct. Okay? Any questions? Okay, what I want you to do, how about instead of this, we do yn xn plus 1. Go ahead and redo the proof for me. Let's, instead of add and subtract xn yn plus 1, we're going to add and subtract yn xn plus 1. So go ahead and rewrite these and you will get different formula. So go ahead, spend 2 minutes on it. Okay? Work it out in front of you if you have pencil and paper. Okay, if this is the case, so that would be yn x plus yn x minus xn yn. So what we're gonna do now is take these two together and take these two together. Okay, and then you'll get a different formula. All right, but they will both give you the same answer. Okay, all right. So for example, if we have del of n 2 to the power n, so if you take this is x, this is y, then it's going to be del xn will be n plus 1 minus n EYN 2n plus 1 plus xn plus n 2n plus 1 minus 2n. Okay? And that is 2 to power n plus 1 plus, and remember what this is, plus n 2 to power n n. Okay? And so if we do it directly, del n 2n without using the formula, that will be n plus 1, 2n plus 1 minus n 2n. And so if you factor 2 to the power n, will be n plus 1 times 2 minus n 2 to power n. And that is gonna be 2n plus 2 minus n, 2 to power n, and that is n plus 2 times 2 to power n. And if you do this one, what is this? If you factor 2 out, this will be 2 by n plus n 2n. That is 2n, 2 plus n. You see they are the same. So we did it directly without applying the formula, and then we applied the formula, and they both give you the same answer. Okay? Now everything is in the book. If I am waving my hand on certain things, these are basic identities, basic math. So now let's do the quotient rule. The quotient rule, remember, if you have f of g from R into R, this is in calculus, then d of dt of f over g is f of prime g minus f of g prime over g squared. Again, unfortunately, this is not the case in the discrete. So I don't remember the formula, so let's go ahead and do it. So let's say we have xn over yn. That is xn plus 1 over n plus 1 minus xn over yn. Okay? And let us take a common denominator. Common denominator is going to be yn plus 1. That will be yn xn plus 1 minus xn yn plus 1. Okay? So now what we're going to do is add as before and subtract xn yn from the denominator. So with this in mind, it's gonna be yn xn plus 1 minus xn yn minus xn yn plus 1 minus xn yn over yn e of yn. Okay, so let's use the word e, the shift. Okay, so let us take this together. So this is xn. No, let's factor yn will be xn plus 1 minus xn minus, let's factor xn will be yn plus 1. Let's see. Yn xn plus 1 minus xn. How about if I take the plus minus, I took xn, yn plus 1 How about if I take plus here, xn, and that will be, shouldn't make a difference. Maybe I need 1 plus, 1 plus. So I need, maybe I could take, I don't know what the answer is. We're trying to work the answer together. So if I take, oh, did I make a mistake? Oh, this should be plus, guys. One of them should be plus because I took minus xn yn plus xn yn. Okay, now it should work. So let's take yn as a common factor. We get xn plus 1 minus xn, okay, minus xn yn plus 1 minus yn over yn e of yn. And you will see that this is yn del xn minus xn del yn over yn e of yn. So this is the only difference. Okay. All right. Any questions? So let's do an example. Let's do e of n over n plus 1. So that is x and y. So if we apply the formula, so this is y, this is x. If we apply the formula, it's going to be yn n plus 1 times del xn times del n minus n times del yn over n times n plus 2, because EYN is n plus 2. So this will be n plus 1 times n plus 1 minus n minus n, that will be n plus 2 minus n minus 1 over n times n plus 2. Okay, so this is n plus 1 minus n over n times n plus 2, and that is 1 over n times n plus 2. Okay? So this is applying the formula. All right, so let's do it directly. If we do this directly, we don't need to apply the formula. If we do it directly, so we get, oh, sorry, this is del, not e. Del of n over n plus 1, that will be n plus 1 over n plus 2 minus n over n plus 1. N plus 1 over n plus 2 minus. Well, let's see what this is. N plus 2 over n plus 1 will be n plus 1 squared minus n times n plus 2. Okay, so let's expand this out. This is n squared plus 2n plus 1 minus n squared minus 2n over n plus 2 times n plus 1. And so this is, so what happened? N squared, 2n minus 2n go away. You are left with n over n plus 2, n plus 1. And well, the formula, what does the formula say? The formula said yn EYN. Oh, sorry. Yn is n plus 1. Okay. The formula says yn over del yn, whatever that is. So I miswrote. So you see both answers are the same. Okay. There. All right. Now there are some other examples in the book that you can do. Any questions so far? All right. Now let's do, remember the factorial function. Remember, if you have d of dx of x to power r in calculus, that would be r x r minus 1. Remember that? Well, so now for the factorial function, assume t to power r is defined, then del of t to power r is r t to power r minus 1. Okay? And the proof is in the book, but I only do it for r being a positive integer. So the proof in the book is only for r being a positive integer. Okay? All right. Any questions? All right. And similarly, del square of t to power r is r minus 1, tr minus 2. So this is the same as d squared over dx squared of x to power r is r times r minus 1, xr minus 2. So there is only similarity only for the factorial function. Okay? Factorial and power rule. And the same thing, for example, del r t to power r is r minus 1, r minus 2, 3 times 2 times 1, and that is r factorial, provided r is a positive integer. Okay? And del r plus 1 t to power r is 0, because you're taking more derivative than the power. So this is similar to dr plus 1 over dxr plus 1, and that is 0. Okay? Any questions? Let's do an example. Example. This is example 1.10. Solve 3xn plus 2 minus 6xn plus 1 plus 3xn, and that is equal to n times n minus 1. Okay? Well, so basically, that is, we're going to find xn that satisfies this. Basically, this is what solve mean. Find the sequence that satisfies this equation. Okay? So we're going to find the sequence. Well, we don't know. We have not learned any rules yet, except what we have so far. So let's divide by 3. And you're going to have xn plus 2 minus 2xn plus 1 plus xn, and this is 1/3 n times n minus 1. Okay? So what is this? You notice this one is del square of xn equal to 1/3 n times n minus 1. You see that? And that is 1/3 times del square of 1/12 of n to power 4. Because take the derivative of n to power 4. If you take the derivative to n to power 4, you put it here. You put it here. So from here, what is del square? Del square of n to power 4. That is 4 r times 4 minus 1 to power n to power 2. You see that? So this is 1/12 n to power 2. Okay? So are you with me? So basically, so this one is del square of n to power 4/36. Okay? The way I showed you. Because you remember, you need to get n times n plus 1, so these will cancel with those. Take the second derivative of that. You will get this. All right? Why? So you see del square of n4/36 is 1/36 del square of n to power 4, and that is 1/36 of what? Of 4 times 4 minus 1 and the square, correct? And that is 1/3, okay? And the square, and that is 1/3 times n minus 1. You see how I got this? You see, so this one is this one. Take a look at it for a second. Okay? So what this tells me, so you have this equal to that. So this implies if and only if xn is n to power 4/36. Okay? So that is the solution. And you know how to write n to power 4. So n to power 4, this is 1/36 of n minus 1, n minus 2, n minus 3. That's what it is. Okay? So that will solve this one. Okay? Any questions? So that is a good example. And there are some formulas. So we have a table. So we are learning, what we are learning so far is the calculus on the discrete line. That's what we are learning. Okay? You remember in calculus, you taught how to differentiate, integrate, and this is what we are doing. On a discrete line, we are learning how to manipulate, how to differentiate. The differentiation means the delta difference. Okay? And how to integrate, and we shall see that today. What does integration in that sense mean? The parallel term to it. What does that mean? All right. What else do I have? Oh, we have a table. So let's take a look at table 1.1. It says if you have Fn, and this is del of Fn, if you have constant C is 0, An is A minus 1 An, sine An is 2 sine A over 2 cosine A times n plus 1/2. And cosine A times n, A is constant, is minus 2 sine A over 2 sine A times n plus 1/2. And then log of A times n is log 1 plus 1 over n, and the log of gamma function is the log of n. So that is a table about differentiation. Okay? Any questions? I mean, let's take a look about log an. That is log A times n plus 1 minus log an. Okay? And that is log of A. This is log of A times n plus 1 over an. Is that right? So that is log of an plus A over an, and that is log of an over an plus A over an, and that is log of 1 plus 1 over n. Okay? You see where did this come from? All right? You remember I used the formula log u over v is log u minus log v. That's what we used. Okay? Any questions? All right, let's take a couple minutes of a break. Let's stay online. I'm not gonna stop the video, okay? Just a couple minutes and we'll be back. Just wanna get a drink of water, right? I mean, this table is like the table for like what you have the derivative of a constant function of n of cosine, sine, log, and the a to power n is the exponential, basically. Okay? So all right. So let's talk about, remember in calculus, you had the antiderivative. Antiderivative. Okay? It says if you have f from the real to the ear, and if f is the antiderivative of f, that means, what does this mean? That means df over dt equal f. Then the integral of f of t dt is equal f of t plus c. This is in calculus, remember? Okay? So now for us here, if you have x from z into r, and if Fn is the anti-difference. You see the difference between the two? This is the antiderivative. Here is the antidifference of xn. And what this means is del Fn equal to xn. Then we will write xn equal Fn plus c. Okay? So instead of the integral, we write summation. So then this is the summation of xn equal Fn plus constant c. Okay? So this is our notation. All right? Any questions? And we're going to elaborate on this to come. So if you see, if you notice that del of a to power n is a n plus 1 minus a n, and that is a n times a minus 1. Okay? So del of a n over a minus 1 equal a n. All right? So what this means is, a n over a minus 1 equal a n plus c. This is what it means. So that means this one is the Fn. So this is the Fn, and this is your Xn. Okay? Oh. Sorry. This will be Xn, the other way around. And that is the Fn. Anyway, So you will see what's really going on here. Sorry, I think I got it wrong. Sorry. No, this is not correct. This is not correct. If I take the sum, so what I meant to say is the AN is AN over A minus 1 plus C. Okay? So again, this is your XN, and this is your Fn. Why? Because del Fn equal Xn. Okay? You can verify it. Why don't you take compute for me, compute del AN over A minus 1. Go ahead. What is that equal to? Go ahead and compute it. Let's see. Yeah, she did get a 3 today. So del AN over A minus 1 is AN plus 1 over A minus 1 minus AN over A minus 1. That is A minus 1, AN plus 1 minus AN. Factor AN out. You get A minus 1 over A minus 1, and you will get AN. So you'll see that. So del Fn is Xn, is AN. This is what it means. All right. All right. So this is the antidifference. This is how we define the antidifference. Okay. The antidifference, the antidifference sum is linear. That is sum of C1xn plus or minus C2yn is C1xn plus or minus C2yn. So it's linear. Okay. All right. Any questions? So let's say you want to solve. This is an example. Solve xn plus 2 minus 2 xn plus 1 plus xn equal a to power n, and a is not equal to 1. Think about this for a second in terms of sum. What do you think? Well, you notice that this one is del square of xn, and that is equal an. Correct? So what this means is, this means that if you take the sum of del square of xn, that is the sum of an. And what is, so this means del xn equal to an over a minus 1 plus c1. That's what the sum of that is, the antidifference. Okay? Now, do it one more time. Do it one more time. The antidifference of C1 is basically, it is C1 times n. So let's hit it one more time. Del xn equal to an over a minus 1 plus C1. So this is xn equal to 1 over a minus 1 an plus C1. That is 1 over a minus 1 times an over a minus 1 plus C1n plus C2. Okay? So the answer is xn is an over a minus 1 squared plus C1n plus C2. All right? So this is what it is. So we have a table again. We do have a table. So let me give you the table that as we did for the differentiation. So take it, finish this, see if you have any question. Okay? So every time you take a sum of the antidifference will get lower by power 1. Okay? All right. So let's give you a table. All right. All right, here is a table. Table 1.2. This is the antidifference of basic sequences. Okay? So we're going to have Fn and sum of Fn. So there's going to be n to power r, and this is n to power r plus 1 over r plus 1 plus c. A to power n is a to power n over a minus 1 plus c, and a is different from 1. Okay? Sine a times n, no, oh yeah, will be minus cosine a times n plus 1/2 over sine a over 2 plus c, and a is different from 2 pi or 2k pi. So k is 0 plus minus 1 and so forth, because the sign will be 0 in the denominator. Cosine an is sine an plus 1/2 over sine a over 2 plus c, and a different from 2k pi and the same k log n is log of the gamma function n plus c. And if you have n, choose r, it is n, choose r plus 1 plus c. Okay, so this is the table. All right. So these are some basic formulas that should help you out for the antidifference. Okay. Now, what happened if you have, so you remember you recall in calculus, if f is the antiderivative of f, then the integral from a to b f of t dt is f of b minus f of a. This is one of the fundamental theorem of calculus. So what is the parallel or the analogous theorem to this one? Well, so for discrete or difference or discrete, we're gonna first of all, we're gonna adopt the notation that sum from a to b of k equal xk equals 0 if a is bigger than b. Okay, so we're gonna adopt this notation. I have not given you formula, I have not addressed the parallel theorem to the fundamental theorem of calculus yet. But you and I today are agreeing on this notation, that if you sum from a to b, the sequence, you get 0 if the lower index is bigger than the upper index. This is what we are agreeing on. Okay? All right. So let's see what we have now. So the antiderivative, all right? So basically, if f of n is the antidifference of f of n, then the sum from n equal a to n equal b of f of n is f of b plus 1 minus f of a. I need you to notice the b plus 1. You see, in calculus, it was a to b f of t dt was f of b minus f of a. Notice the difference. Okay? So you go to b plus 1. So how we do the proof? So n equal a to b, so we write b of f of n equal to n equal a to b del f of n. What do you think? And that is n equal a to b f of n plus 1 minus f of n. Correct? So we're gonna let u equal k plus 1. So this will be, n plus 1. So for n equal a, u equal a plus 1. For n equal to b, that is gonna be b plus 1 f of u minus, okay? So let's see if I can change it in both. Minus, and this here is u. So this is minus n equal a to b f of n. Okay. Now, which is the same as u equal a plus 1 to b plus 1 f of u minus u equal a to b f of u, because n is a dummy variable. Now, let us evaluate the first one at b plus 1. F of b plus 1 plus u equal a plus 1 to b. If I evaluate this at b plus 1, the first point before b plus 1 is b. F of u minus, let's evaluate this at a. And we are still left with the next point after a is a plus 1 to be f of u. You see that? Now take a look at this one. This one and this one cancel out. And what are you left with? F of b plus 1 minus f of a. There you go. Okay? Any questions? Try to understand it and see. All right, so the alternative in sometimes we usually sum to n. So, I mean, alternatively, if we have del f equal f, then let's say we have s equal to n naught to n minus 1 fn, that is fn minus fn naught. Okay? Because you have to increase it by 1. So this is f of n from n equal to n0 or s to n. Okay? This is the notation we will be using. It's getting so dark outside. This is storming here. Any questions? Okay, let's do some examples. Compute k equal 1 to n minus 1 a to power k. So what is f? Remember, if you look at the table, an, the antidifference of it is an over a minus 1. So the sum of an is that. So that is ak over a minus 1 from k equal 1 to k equal n. And that is an over a minus 1 minus a over a minus 1. Okay? You see that? And of course, I'm assuming a is different from 1. So for example, if you have k equal 1 to 3, 2 to power k, that is 2 to power k over 2 minus 1 from k equal 1 to 4. And that is 2 minus 1 is 1, will be 2 to the 4th minus 2 to power 1 will be 2 cubed minus 2. And how much is that? That is, if you factor 2 out, so will be 2 squared minus 1, so 4 minus 1, so that is 6. Okay? No, more than that. How is that? Oh, 2 to the power 4, sorry. Minus 2 cube minus 1. So that will be 2, 8. So that will be 2 cube. 2 cube is how much? 2 times 2 is 4 times 2 is 8. 8 minus 2 is 6 times 2, that is 12. If you sum this, if you sum it, will be 2 plus 2 squared plus 2 cubed. So that is 2 plus 4 plus 8. Oops, should have gotten 16. Why didn't I? So I am getting 2 to the 1, 2 cube. So that is 16. And here I should have gotten what? 2 to the 4th minus 2 to the 1. 2 to the 4th minus 2, that is, let's see. Let's see, 2 to the 4th. Three minus 2. Okay, minus 2. 2 to the 4th. Over 2 minus 1. Made a mistake somewhere here. I'll get back to it.
Professor, I think both answers are 14.
Oh, yeah. That is 14 and that is 14, right? I don't know how to add, do I? So yeah, you'll get 14. Both answers will give you 14. Okay? So you see the important one is you jack this one up by 1, the upper limit. Okay? So yeah, they will both give you 14. All right. What about another example? Another example of k equal 1 to n, k to power r. Well, what is k to power r? N to power r is n r plus 1 over r plus 1. So that is k to power r plus 1 over r plus 1 from k equal 1 to n plus 1. You see that? So we used the table and then we used upper limit plus 1 minus the lower limit, correct? And so that will give us k to power n plus 2 over r plus 1 minus k over r plus 1. Sorry. Actually, there was a mistake here. Remember, I am integrating with respect to k. So this is k equal to 1 to n plus 1. K, not r. So this is n plus 1 to power r plus 1 over r plus 1 minus 1 to power 1 over r plus 1. Okay? This one is 0, and then you will get this one. N plus 1, r plus 1 over r plus 1. This is since 1 to power r plus 1. This is r plus 1. 1 to power r plus 1 is 0. So this is what you get. Okay, let's do one more example and we will stop. Or I will do one more thing. Let's do one more example. Okay. Oops, I want the table. All right, let's do one more example. Let's do k equal 1 to n k squared. Now, k squared is equal to k squared plus k. See exercise 1.11. Okay? So this is k equal 1 to n of k squared plus k equal 1 to n k. Okay? And that is k 3 over 3, okay, from k equal 1 to n plus 1, all right, plus k squared over 2 from k equal 1 to n plus 1. What am I using? I am using this one. N to power r is n to power r plus 1 over r plus 1. You see what I'm using? I am using this one. And n is substituted for k, or k is substituted for n in my example. So, and if you do this, you're gonna get n plus 1 cubed over 3 minus 1 plus over 2 minus 1 squared over 2. This is 0, this is 0, so you get this one minus plus this one. Okay? So you can simplify this a little bit more. This is n plus 1 will be n plus 1 times n minus 1 over 3. And this one will be n plus 1 times n over 2. So you can take a common denominator, okay, and then try to simplify this. Okay. Now there are two things I'm gonna do in a second. So we're almost done, but let me do two things. So recall from k equal n0 to n minus 1, f of k, or f of k is f of n minus f of n0. So this is basically what I have is del fn equal fn. So this is the same as k equal n naught to n minus 1 del fk on the inside. That is immediately fn minus fn naught, if you can have that. Okay, we already did this, all right, and so these two are similar if del fn equal fn. Moreover, okay, del n of k equal n naught to n minus 1 of fk That is Fn. So now what you are doing, you're summing and taking the delta with respect to n minus 1 with respect to n. Okay? Let's do the proof of that. I'm gonna write it in the next one. And then I will stop. So I have del n of k equal n naught to n minus 1 fk. The del n mean you're taking the difference with respect to n. So del n means difference with respect to n. Okay? So this is k equal n naught to n fk minus k equal n naught to n minus 1 fk. Evaluate this at n, fn plus k equal n naught to n minus 1 fk minus k equal n naught to n minus 1 fk. This and this cancel. Yes, and so this is Fn. That's it. So I don't know what I wrote here. Yes, it's Fn. You see what we did? We just took the difference with respect to n. So we added n plus 1, and we kept the other one minus. And I evaluated the sum at n, you get Fn, and then the term that preceding k evaluated at n is at n minus 1, but these two cancel out, and then you are left with Fn. Okay? So for example, if you want the delta of k equal to 5 to n minus 1 k squared, right? That will be n squared. Okay? All right? And the other one will cancel out. Okay, I'm gonna stop here, and I will give you, I'm not finished yet. I will finish the homework. I will finish this tomorrow, this section I have. Remember in calculus, we taught you how to do integration by parts, and now next time, tomorrow, we'll teach you how to do summation by parts. Okay? And I'm gonna stop here, and you have a good rest of the day. All right, thank you. Any question before I stop recording or log out? Okay, I'm gonna stop recording.